Greetings to all the viewers. Now we are conducting the session based on the extraction and analysis of non-polar terpenes. This is taken the part of that natural products. The content retrieved from textbook of natural products nurturing livelihood, right? Where we are conducting the series of sessions based on these natural products. Although you are aware about natural products are very essential for the survival of the livelihood. That's the reason why various kind of natural products are available like enzymes, proteins, vitamins. You can go for these alkaloids, terpenoids, carbohydrates, proteins. So many kind of examples comes in this category. In the continuation to earlier session, we are going to discuss about the content called terpenes, right? So, series of sessions whichever conducted based on these terpenoids and also natural products available at the channel called World of Competitive Chemistry. Not only this, chemistry related examination point of view and various concepts also incorporated into the channel called World of Competitive Chemistry. Now, we are going to discuss about extraction and analysis of non-polar terpenes. Most of the primary linear terpenes and cyclized terpenes without a decoloration and exclusively composed hydrocarbons. Terpene meant for hydrocarbons only, right? So these are the molecules said to be non-polar in nature. Wherever oxygen, nitrogen, sulfur, such heteroatoms are located within the molecule, then only they are said to be polar. Polar is nothing but partial charge delocalization will be there. Non-polar meant for only made up of hydrogen and carbon only. This is the way non-polar terpenes taken into the picture, and these how these compounds will be extracted, how they analyze, that topic is going to be discussed. The terpenes 15 are fewer carbon atoms if taken with only carbon and hydrogen composition. They are highly volatile in nature, and the small size being they are less than 15 carbon atoms, the less than 3 isoprene units got combined, so that they are tiny in nature, smaller in the size, and polarity will be less for the molecule. Emission into the allowing emission into the atmosphere easily evaporated, being they are volatile in nature. Extraction of these compounds is somewhat critical, and the analytical methods for these volatile terpenes are going to be discussed over there. Non-volatile terpenes are somewhat stable and they can be analyzed. Very non-polar organic solvents like hexane is suitable extracting reagent for those molecules. Using silica as a stationary phase, chromatography is another alternative tool for the extraction process. Chromatography is the better tool for the separation of organic components, right? Here is also terpenes can be easily analyzed, separated, and purified as well, right? Usually, terpenes with a more number of carbon atoms elute very slowly because being they are high molecular weight compound, heavy in nature, so they're slowly eluted compared to the lightweight molecules. But cyclized terpenes can elute faster corresponding to non-cyclized molecules. This is the kind of rate of elution, rate of a flow of those molecules with respect to their speed, with respect to their number of carbons, with respect to their what dimensions, like whether it is cyclic molecule or open chain molecule. In this protocol, we will describe how they extract a linear hydrocarbon molecule squalene from the plant is extracted. That process is going to be discussed in detail. Squalene is the kind of sesquiterpene. 3 isoprene units if combined, 30 carbon atoms containing molecule it will be. So this is the molecule and the precursor for all triterpenoids. Triterpene means for 6 isoprene units are going to be combined. 6 into 5 carbon atoms. 30 carbon atoms are the composition for this squalene molecule. It is the tetracyclic ring system, means 4 annular systems are allocated for this molecule, and also pentacyclic saponins are also taken part of this one. So squalene taken into the consideration now. Limonene is isoprene units, and how the hydrocarbon fabrications are possible, and all these are the part of non-polar terpenoid. Their tabular representation is provided for by their understanding. If you want to know about limonene, his structure is taken only one ring system with the cyclohexene skeleton and the side chain isopropenyl branch, and here is the methyl. And this lemon from which you are able to extract this limonene. So here mint, juniper, rosemary, pine, from which you are able to extract this one. Alpha-pinene is the another category of the example bicyclic ring system with the geminal dimethyl and another methyl substitution within the molecule. And pine trees, you are able to extract this compound. Rosemary as well, right? So beta-myrcene is another category. You can locate the kind of open chain molecule where the exocyclic double bond, open chain molecule only, so that here is the terminal double bond and here is the branched double bond you can locate. From the mango, hops, thyme, and the lemongrass, you are able to extract this beta-myrcene in the economic quantity. Extraction process we are discussing in detail. Linalool is another example where you can locate open chain molecule. Once again, where hydroxyl functionality is the part of that with lavender tree is the economic source of this extraction process. And here, caryophyllene is another molecule you can find over there, puckered ring system with the side chain cyclobutane with the additional branching upon the molecule, addition substitution upon the molecule. Here, black pepper, rosemary, and hops are the important sources from which you are able to extract this caryophyllene. And humulene is another example. It is the kind of molecule you can locate. Isolated double bonds are present within the molecule. Again, puckered ring system is present, non-aromatic it will be. And here you can find the kind of seeds, fruits from which you are able to extract, and the plant is named as hops, right? Humulene will be extracted from that. It is also the kind of terpene. In order to extract such a kind of molecules, there is the common procedure for the non-polar terpene extraction process. Scale capable of accurately weighing 0.1 milligrams plus or minus precisely. So this weighing capability is required. Minute quantity of compound supposed to be analyzed. Glass wool is the another component required, and the glass serological pipettes are also the kind of apparatus required for this one. Glass partial pipettes are also required. Glass vials. Glass vials also important in order to extract these components. All these are the required one, and reagents like liquid nitrogen is essential, gaseous nitrogen as well. Silica gel taken over there. This is the way kind of extraction process carried. Simply, you can notice the column chromatography. Large silica gel column was taken, and the glass wool is placed here at the bottom of this burette. And the small silica gel column is prepared. The disposable glass posture pipette. The glass wool is indicated within the molecule like this. So this is the way fabrication of this column chromatography is possible. Right. Silica chromatography columns are prepared for isolating terpenes and terpenes in the small scale. Very small fractions of terpenes can be better extracted, better separated from the impurities whichever present in the food from the plant origin. So this is the way column chromatography is more suitable, where silica is taken as a stationary phase and the suitable solvent, simply hexane, is taken as a mobile phase. Glass wool is used as a plug in the column, and the column can be overlaid with a small amount of sodium sulfate. The sodium sulfate is also added within the column. That used to absorb the water contamination. If any water content is there within the molecule, can be better absorbed by the sodium sulfate, which used to dry the entire reaction mixture, right? So water droplets will be absorbed by the sodium sulfate. Now, Agilent GCMS spectrometer can be applied over there, to which it is directly connected, and columns are taken. HPS MS columns are equipped over there, and Agilent 5975C mass spectral detector is also connected with that. In order to go for the complexity of the molecule will be analyzed and revealed. Extraction solvent better suitable will be hexane in combination with ethyl acetate. One is non-polar, and either is a polar solvent taken in 85:15 ratio, that is volume by volume ratio, right? So both are taken. Maximum extent of hexane, tiny quantity ethyl acetate like 85:15. Molar ratio, volume by volume, can be taken as a solvent mixture or as a mobile phase. HPLC, high pressure liquid chromatography, is the important method applied for the separation process. And here, alpha cadmium is the kind of compound to be diagnosed by means of this process. Hexadecane is the compound which purchased from the source called sigma aldrich, and the extraction of plant material with the organic solvent taking place. Initially, you are supposed to do the step-by-step manner. In the first step, you need to measure 100 milligrams and 1 gram of plant extract. Wherever, for example, you are taking the plant from which economic quantity of terpene to be extracted, for that purpose, 1 gram or else 100 milligrams of that plant material to be taken. Amount of plant material you use depends upon the purpose of the extraction, what purpose you are utilizing. So minute quantity if enough, you can go for the 100 milligrams. If required in the some larger content, so that 1 gram is sufficient. This is the way for which purpose you are extracting that will select the amount of the starting plant material. Scalene extraction is taken starting with the tobacco plant, and fresh tobacco leaves can be taken weighed over there, and 50 milligrams tobacco leaves material to be taken, and that is properly washed, dried, and powdered. Now, next we may go for the grind and extract the process. So here the entire plant extract whichever taken will be finely grounded into the powdered form, and liquid nitrogen can be taken, that to be filled in the glass vial, either by the mortar and pestle can be used in order to transfer that one and ensure this sample of the glass container before adding the solvent. Plastic container will reach the components into the organic solvent. Analytical analysis or HPLC columns are to be connected over there. So grinding is required later on. Filling into the vials are required. The fine powder to be taken into the vials, and organic solvent combination is also taken. Now, the important step will be, this is only the important step where solvent selection. The content what you are going to extract to be soluble in the selected solvent, then only it is possible to get the maximum content of extraction. So, extraction solvent to be taken, plant material to be mixed up with the solvent like a hexane and ethyl acetate mixture, as we already discussed, 85% maximum. Larger proportion of hexane non-polar solvent to be taken. Minute quantity 15% extent of ethyl acetate to be added over there immediately after the material has been ground. A crude extract should be transformed the glass vial flask for the shaking at least 3 to 4 hours. Being the entire organic content to be extracted into the solvent mixture, we need to go for that shaking of that one. So the 3 to 4 hours overnight shaking is required. The ratio of hexane, as we already aware, 85 is to 15 volume by volume ratio of that hexane and the ethyl acetate to be taken. Derivatization. Converting the compound into crystalline derivatives, right? So whatever compound extracted from the plant material to be crystallized, crystallization is required over there. Helps to confirm the functional groups and structure. Later on, you need to go for the structural conformation by functional group analysis and the structural elucidation process by means of chemical and analytical methods. Ester formation is required. Whatever compound is there to be converted into ester form, or else oxide form, or else hydrogen form, or else glycosidic form, so that whatever liquid extract will be, they're simply converted into crystalline form. This is the way derivatization is taking place, right? Biotransformations are another important segments over there. Also offers the new route for the production of high quality of the terpenes in the purified form. Phytochemical derivatives will be extracted. Phytochemicals mean for the plant extracts. Simply all the terpenes extracted from the plant origin, so that you can mention them as a phytochemicals only. You can perform glycosylation. Glycosylation is taking place upon the molecule. Glucose can be mixed over there, and methylation simply operated. Acylation is another simple trick for the biochemical transformation in general. Amidation is also the kind of chemical modification, so that the starting material liquid will be transformed into crystalline form. This is the way by transformations occurred, right? So I'm taking the simplest example, quercetin. Quercetin is a terpene. You can locate it is the Raman derivative. Raman derivative it will be. Here's the Raman. Here is the benzene nucleus with the hydroxyl, 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 hydroxyl. Polyhydroxyl system it will be. You are supposed to treat with glucose so that glucosamidation is possible. Wherever that kind of linkage hydroxyl is there, that hydroxyl group will be added with this glucose. If you're adding quantified ratio of this glucose, 1 molar ratio, controlled addition you can designate, so that this only selective hydroxyl group will be treated with glucose and giving rise to glucosidase derivative like this. The entire this fragment will be carbohydrate part, and this above part will be quercetin. This is the way a kind of linkage, new linkage will be originated in between, that is ether linkage, glycosidic linkage. This is the way derivatization. The starting material quercetin will be crystallized by means of that glycosidase derivatization process. This is the simplest example you can clearly observe. Now, let me perform the same treatment of glucose upon isoramidin. Isoramidin can be taken. Here is the methoxy linkage, hydroxy, 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 hydroxy. If this molecule is also gone through the treatment of glucose molecule, it is the carbohydrate. Again, the kind of glycosidic linkage taking place at the same position, at the same kind of linkage pattern, and that molecule generated is isoramidin 3 glycoside formation is possible. This is the way crystallization is accomplished. So by this we can clearly conclude the entire process of extraction of non-volatile terpenoid molecules. Non-volatile terpenoid molecule extraction and how the analysis taking place is clearly manifested over there. Hopefully the session is very informative for your preparation, and we will go with the more informative content in the near future. If you subscribe and follow this channel carefully, so that you will definitely get the worthful information from this one for your preparation, examination, or else any competitive exams. This kind of chemistry content is really helpful for your preparation. Thank you very much for your patient listening. All the content available from World of Competitive Chemistry. Thank you.